What if we built a huge tower on the moon? A tower that could provide future missions with light, power, and guidance technologies that could help astronauts explore our natural satellite. It's not something from a sci-fi book. It's a novel idea from Honeybee Robotics, one of the brightest space technology companies. The lunar utility navigation with advanced remote sensing and autonomous beaming for energy redistribution, or simply Lunar Saber, is a 328 tall pole. It's capable of holding 1 ton of equipment on top of it. But how could we build such a giant construction? No rocket would be able to hold and land such a giant pole on the moon. And building such a tower on the lunar surface without already existing infrastructure would be next to impossible. So, Honeybee might use the deployable interlocking actuated bands for linear operations Diablo system. It uses a rolled piece of metal and bends it into a deployable cylindrical structure that can support really heavy payloads. It would be easier to build it on the moon because gravity there is only 16% of that on Earth. The structure could serve as the base for Lunar Saber. Power is crucial on the moon, so putting solar panels along the sides of the pole would be super useful. The company is now discussing 2 types of solar panels. The first one is like a yo-yo extended from the top payload holder of the tower. It would envelop the metallic structure and allow access to the sun at all angles. The second option might involve the top part of the tower. It could deploy its booms to hold traditional solar panels and then track the sun. Power supply wouldn't be the only Lunar Saber's task. It would also be able to beam power to other devices, track other devices, and provide communication, light, and energy. Let's talk about these functions in more detail. If one mast of the pole was bathing in sunlight while another was lingering in shadow, the one with excess power would be able to beam power to the one lacking it. Plus, similar power beaming could happen between Lunar Saber and rovers and astronauts in spacesuits. To beam all that power effectively, though, the tower would need to know the precise location of those objects. That's where the second technology would come in. Lunar Saber could use a set of sensors to find and track other objects. Basically, anything in a direct line of sight could be tracked and powered by the tower itself. Lunar Saber could also act as a lunar cell phone tower. It would allow wireless communication in its network. And finally, it would be super helpful for astronauts to actually see where they would be going. Rovers wouldn't need to wait out the 2-week lunar darkness. Floodlights at the top of the tower could provide enough visible light for astronauts and rovers, which would allow them to effectively perform their activities at all times. But guess what? The tower could become even more useful. We could combine several towers in a mesh. It would allow astronauts to communicate more effectively. Plus, power could be beamed even from the other side of the moon. It would enable 2 main applications that have been a thorn in lunar exploration's side so far: constant communication with Earth and constant supply of solar power. The thing is, explorations on the other side of the moon are quite tricky, which limits the area of scientific research to the side directly facing Earth. But a strategically placed mesh of Lunar Sabers could allow communication back to Earth, and we would be able to explore the dark side of the moon. Since at least half of our natural satellite is always lit up, if we placed Lunar Sabers correctly around the surface of the moon, there would always be at least one bathing in sunlight. That one sunlit tower would then wirelessly transmit power to others in its line of sight. This process would keep going until power was beamed to the main astronaut's base, supplying them with power even in the cold lunar darkness. Unfortunately, at the moment, such technologies look unrealistic. We're not close to having wireless energy transmission over long distances. Even on Earth, we still need to use batteries and wires. It might be easier to launch many satellites into orbit around the moon than to create a network of giant communication towers. What if our moon was hollow? Would we be able to hide inside in case some terrible catastrophe destroyed our home planet? Well, the supporters of the hollow moon theory believe that it's actually a real option. The hollow moon is a hypothesis claiming that Earth's moon is either completely hollow or has quite a lot of place inside. The thing is, the moon is less dense than Earth, and it seems to support the idea of its hollowness. But according to science, the reason is the fact that Earth's upper mantle and crust are less dense than the heavy iron core of our planet. Then, there's also the claim that the moon rings like a bell. For almost a decade, between 1969 and 1977, seismometers installed on the moon by the Apollo missions kept recording moonquakes. The moon was reported to be ringing like a bell during such quakes, especially shallow ones. On the 20th of November, 1969, Apollo 12 deliberately crashed the ascent stage of its lunar module into the surface of our natural satellite. According to NASA, after that, the ringing continued for almost an hour. This made some people argue that the moon must be hollow like a bell. Later, lunar seismology researched those shallow moonquakes and showed that they acted differently than quakes on our planet, mostly due to differences in type, texture, and density of the lunar and Earth's rock layers. The speed of sound waves in solids is determined by the medium's compressibility and density. No one has ever found any evidence of a large empty space inside the moon. And still, in 1970, Michael Vasson and Alexander Sherbakov suggested a hypothesis that the moon could be a spaceship designed by mysterious extraterrestrial beings. In 1965, writer Isaac Asimov made an observation that added fuel to the fire of conspiracy theories. He marveled at the sheer astronomical accident that the moon fits so snugly over the sun during total eclipses. The sun's greater distance makes up for the incomparably larger size of the star. As a result, it seems to us that the moon and the sun are the same size. The author added that there was no astronomical reason why the sun and the moon should fit so well. So since the 1970s, conspiracy theorists have been quoting Asimov's words about solar eclipses as evidence of the artificial origin of the moon. Mainstream astronomers disagree with such an interpretation, saying that the angular diameters of the moon and the sun don't perfectly match during eclipses. They vary by several percent over time. Many other pieces of evidence confirm that the moon is a solid body that formed after a planetoid crashed into Earth. In the past, scientists thought that the moon appeared after our rapidly spinning planet got rid of a good chunk of its mass. This idea was suggested in 1879 by George Darwin, the son of the very Charles Darwin, the famous biologist. This theory remained popular until the Apollo missions. Then, in 1925, Austrian geologist Otto Ampferer offered another idea, that Earth and the moon could have formed together from a primordial accretion disk, a rotating disk of dense gas and dust surrounding a young, newly formed star, and used to be a double system. The third theory stated that the moon could have once been a planetoid caught by the gravity of our planet. The modern explanation usually involves the giant impact hypothesis. According to it, a Mars-sized space body hit Earth and created a debris ring around our planet. In the end, this ring gathered into a single natural satellite, our moon. But getting back to the hollow moon theory, at the moment, there's no scientific evidence to support this hypothesis. Seismic observations and other data indicate that the moon has a solid interior with several layers, a thin crust, quite extensive mantle, and a dense core. These days, the idea of the hollow moon is considered to be a conspiracy theory.
There are a few theories about how the moon appeared in the sky, and recently a new idea has popped up. But before we discuss this newcomer, let's look at the most popular hypotheses of the moon's formation. The capture theory claims that Earth's natural satellite used to be a wandering body, something like a large asteroid. It had formed somewhere else in the solar system before it was captured by our planet's gravity when passing nearby. The accretion hypothesis suggests that the moon formed in orbit around Earth at the same time as our planet appeared in the darkness of the cosmos. Then, there's the fission theory that says that at one point in its development, Earth was spinning so fast that some of its material broke away and started to orbit the planet. And the giant impact theory, which is the most popular these days, claims that the moon formed during a collision between Earth and another hypothetical planet called Theia, which was way smaller, probably the size of Mars. The resulting debris collected in an orbit around Earth and formed the moon. And now, let's move to the new theory you've been patiently waiting for. According to it, our satellite might have formed immediately, in a matter of hours, after the collision between Earth and Theia. The material from the two planets was likely launched directly into Earth's orbit right after the impact. It formed the Moon and left traces deep inside Earth. In previous scenarios, Theia's remains were thought to have been scattered all over space, mixing with just a bit of the material coming from our own planet. But then, why do we see such shocking similarities between the Moon's and Earth's compositions? Could it be that Theia was isotonically and chemically similar to Earth? Unlikely. But according to the new theory, more material from Earth was used to create the Moon, its outer layers in particular. It might explain this similarity in composition. One more theory also tries to explain this mysterious similarity, the synestia model. According to it, our satellite formed inside a swirl of vaporized rock left by the collision. But this theory can't explain the Moon's current orbit. The new single-stage theory does offer us plausible explanations for both the similarities in composition and the orbit of the Moon. It might also provide us with some answers to previously unsolved mysteries. Since this scenario puts the Moon into a wider orbit and gives it an interior that is not fully molten, it can explain the satellite's tilted orbit and thin crust. In any case, to confirm one of these theories, we need to analyze future lunar samples that will be brought to Earth by NASA's upcoming Artemis missions. Scientists will be able to get their hands on some material from deeper beneath the Moon's surface and compare if real data matches these simulated scenarios. In the past, the Apollo missions already brought back about 1/3 of a ton of rock and soil from our satellite. These samples showed that Earth and the Moon had some remarkable chemical similarities. They could only suggest one thing. These space objects had a linked history. If the Moon had formed elsewhere and been captured by our planet's gravity later on, its composition would be very different from that of Earth. But if the Moon had been created at the same time as Earth, or if it had broken off our planet, the type and proportion of minerals on the Moon would be the same as on Earth. But they are a bit different. The Moon's minerals contain less water than their terrestrial counterparts. The satellite is also richer in materials that form rapidly at high temperatures. That's why the most accepted model of the Moon's formation these days is the giant impact model. Meteorites coming from the Moon are a great source of data for studying the origins of our satellite too. They can tell us even more about the Moon than Apollo samples, all because such meteorites come from all over the surface of the Moon. Meanwhile, Apollo samples were collected just in one place near the equator, on the near side of the Moon.
Okay, I officially give up on the hope that the Moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the Moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the Moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the Moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the Moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the Moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron. just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire Moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the Moon's surface and its core, called the mantle, has been moving around as the Moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the Moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the Moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve: what caused the Moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the Moon's magnetic field. Knowing what the inner core is like can help us better understand the Moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the Moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the Moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Our moon exploration project started out in 1969. Sure, there have been some problems along the way, but astronomers are certain we'll get back up there pretty soon and with better knowledge and technology. However, there's an 800-year-old trick that might become way more useful than fancy GPS tech and powerful rockets. It's called the Fibonacci sphere. Some scientists at a Hungarian university stumbled upon this idea while studying the moon. They believe it might be useful to better understand how the moon spins and how it's a bit squished while it goes around Earth. You might believe that our planet and its satellite are these perfect little spheres floating in space. Well, that's not true. They are in fact like slightly deflated soccer balls because of all the gravity, rotating movements, and tides. The GPS technology we use here on Earth is already adapted to these less than perfect ball proportions. Remember, our planet is a bit flattened at its poles. If we're going to make a map system for the moon, we need to do the same for its shape, called a solenoid, or what scientists call the moon's version of our Earth's shape. Since the moon is less compressed than our planet, scientists have been taking a shortcut until now. They've been looking at our satellite as a simple ball shape. However, with all these new projects coming up in the following decades and even some exciting trips we might end up having on the moon, we need to be more precise. Scientists now believe we should get the real data and start drawing an accurate picture of the moon. Here's where the Fibonacci sphere comes in handy. It's a clever solution that's been used by mathematicians to spread points out evenly on a ball. Scientists recently used it to map around 100,000 spots on the moon using data previously collected by NASA. And what they found was crucial for our understanding of the moon's shape. For instance, we now know that our satellite's poles are about 0.3 miles closer to the center compared to the moon's equator. Sure, it might seem like a tiny detail, but if we adjust our GPS software accordingly before we land on the moon again, it might save us from getting lost up there. This level of math hasn't been done since the 60s for the moon, but we already know it works wonders here, at home, so it only makes scientists better prepared for future missions. This isn't the first time people have used Fibonacci's findings to come up with clever solutions. We've also seen it put to work in finance, agriculture, and in computer science. Let's see where it all came from. Legend has it that the Italian mathematician Fibonacci wasn't really that interested in mathematical sequences at first, but rather in rabbits? So, he came up with this interesting puzzle. What happens if you place a pair of rabbits in a certain space for a year? He also set some theoretical rules. For starters, all those bunnies come in boy-girl pairs, and they can start reproducing after just a month. Each month, each bunny pair adds one more pair of bunny offspring. The last rule was that all bunnies would be invincible for the year. Doing the math, he got this series of numbers. 1, 1, 2, 3, 5, 8, and so on. If you look at this series again, you'll notice that every number is the sum of the two before it. The first two, that's your starting bunny pair. Next, you'll see the number 2, which is the first pair and their first offspring pair. Word caught on about this interesting sequence, and math lovers began studying it more closely. They started seeing this pattern very often in nature, like in how leaves grow on a plant or how seeds arrange on sunflowers. There's even a little experiment you can do to check it out. Start by grabbing some paper and a pen. Try drawing the Fibonacci spiral. Start with a tiny circle, then go bigger and bigger using those Fibonacci numbers. The first circle should just be a tiny dot on the paper, or the equivalent of 0. Next circle, 1 unit. Another circle, still 1 unit. Keep it going and you'll see that the circles form this spiral pattern. Even as it continues to grow, it keeps its shape. You might have also stumbled upon the Fibonacci spiral as a symbol of hypnosis. In all fairness, there's little evidence you can confuse someone by making them stare into a spiral for a while. But its effects on our focus and our optic nerves can't be ignored. After you've stared at a spinning spiral, you might see how objects get smaller or bigger depending on the direction of the swirl. It's easy to understand why some experience this sensation as hypnotizing. This interesting series of numbers appears in our day-to-day lives, even if we don't notice it. It can also be used in more practical instances, like converting miles to kilometers. Let's look at the series 1, 2, 3, 5, 8, 13. Pick any two numbers side by side. Say 13 and 21. Do the calculations and you'll notice that 13 miles is about 21 kilometers. Same with 34 and 55. Music and math might not seem like they're connected, but if you had asked the great Mozart, he probably wouldn't have agreed. It seems he was very passionate about numbers from early on in his career. He loved finding cool number patterns in music, like some sort of hidden messages. His own sister even remembered him doodling math all the time, even on the sides of his music sheets. Some scholars believe he might have even played around with the Fibonacci numbers. If that's really the case, then he might have used the ration to balance out parts of his tunes. What about other types of art? Well, it's also said that Leonardo da Vinci used the golden ratio in his masterpieces, like the Vitruvian Man and the Mona Lisa. Also, when it comes to great pieces of architecture, the Parthenon might have used this pattern too. Anytime you see buildings with columns spaced just right, you can be certain that's where the builders drew inspiration from. The Great Pyramid of Giza is another great example. There's no official record to prove it, but the pyramid's shape is so close to the golden ratio that it's kind of obvious. You'll also see this pattern appearing naturally in our environment. Go out in our garden and check to see if you have any pine cones lying around. See those scales? They're set up in a pattern according to the Fibonacci sphere. Even the bones in our body seem to be growing based on the same proportions. We've got one torso, one head, and one heart. Then there's stuff that comes in pairs. Our arms, legs, eyes, and ears, for instance. For the number 3, think about the composition of our limbs and the 3 main sections in our hand. The wrist part, the middle palm part, and our fingers, which are also split into 3, by the way. Oh, speaking of fingers, their bone lengths have this ratio too. This design helps our fingers move smoothly, especially when grabbing objects. The Fibonacci sequence can be seen in the way ocean waves curve, and how rivers split and flow too. Weather patterns can also follow this rule. Some whirlpools and hurricanes form and spread out in the same way the Fibonacci spiral does. Zoom out, and you'll see that spirals aren't just found here on Earth. They're also everywhere in space, and it isn't random. Most galaxies, including our Milky Way, are spirals. Think of it like this. Generally, stars in a young galaxy don't all appear at once. Some are faster when developing, others take their time. This makes gravity pull in different ways, making the young galaxy spin like a disk. As it spins, different levels of gravity stretch it into getting these spiral arms. On the flip side, if all the stars in a young galaxy appear at the same time, gravity just smushes it all into an egg shape, or what the astronomers call elliptical.
About 8 billion inhabitants of planet Earth found out the same terrible news in one day. Someone saw it on TV. Others heard it on the phone while scrolling through social media or listening to music. Some witnessed this news in a dream while sleeping. Someone's voice said it in all languages to ensure everyone understood it. I have good news and bad news for you. Let's start with the bad news. You're all characters in YouTube videos in which your planet gets into a situation where the moon breaks in half. For the audience, it will be a hypothetical story, but for you, these events will become a reality. The good news is that I was joking. There is no good news. But don't worry, the apocalypse won't start on your planet. Maybe just a little bit. Have a nice day. At first, the entire population panics. Then, a few days later, everyone calms down. Maybe it was a mass hallucination, and the moon will be all right. But at this moment, scientists have discovered the danger. A colossal meteorite is flying towards us from the distant depths of space. This meteorite is super fast and pretty flat, but has sharp edges. Fortunately, it will miss the Earth by a few thousand miles, but the moon won't be that lucky. The meteorite flies through our Earth's only natural satellite directly in the middle. So it passes through the moon, sweeps past our planet, and flies away into distant space. At this moment, all people can't take their eyes off the moon. The meteorite cuts it perfectly in half, gently, clearly, painlessly. So, what shall we do now? Will the Earth survive this? Our satellite breaks into 2 equal parts, but fortunately, they don't fly away from each other. The moon's great gravity attracts them back like a magnet. Scientists are sure that the parts will connect in a couple of billion years, and the moon will become the same as it used to be. But the coolest thing is that people won't feel any changes. Everyone around the world will celebrate this good news. The voice was wrong. But then, another problem appears. A massive meteorite in the form of a shoe is flying from the deepest space to us. It enters our solar system and approaches the Earth at high speed. The space boot crashes into one half of the moon and then flies away. Now, the moon is definitely breaking into 2 parts. The first half remains in the same place. The second one is flying towards us. A small meteor shower begins on Earth because of the falling moon fragments, but it's not so bad. Most of these rocks are burning up in the atmosphere. But almost the entire split-off half is falling apart around the orbit of our planet. It forms a stone belt. Now the Earth is like Saturn. Rotating fragments destroy part of our artificial satellites. Communication and the internet work inconsistently. It takes people a couple of years to restore a stable connection. The International Space Station no longer exists. Luckily, all the astronauts managed to return to Earth before half the moon got to them. So, moon rocks are flying around the planet, and people see half the moon in the sky. Life doesn't change much for the first few days, but those who live on the coast of the seas and oceans notice the consequences. The moon used to influence the tides. It was flying around the Earth and made oceans take an oval shape. There were tides on the side where the moon was closer. There were ebbs on the opposite side. But now, this schedule is wrong. Half of the moon attracts less water. Yes, the moon lost half its weight and began approaching the Earth. But its gravitational force has become weaker. Seabirds, many species of fish, sea turtles, and other coastal animals may not survive these changes. Their natural instincts associated with the moon help them determine the time for getting food, breeding, and flying south. For example, tiny turtles expect a strong tide in the morning. They run to the water, but the water doesn't reach them. Turtles can't hide in the ocean in time and become dinner for seagulls. Crabs can't lay eggs because the tide has started earlier than usual. Wolves go mad in the woods. They howl loudly every night and can't stop. The whole natural world can't understand what's going on. The human body is also feeling some discomfort. Many people have low and high blood pressure, and some experience severe headaches. Half of the moon changes the entire ecosystem of the planet. Adapting to new conditions will take several tens, maybe hundreds of years. A couple of weeks pass, and people notice the days are now shorter. The moon always slowed the Earth's rotation and made one day last 24 hours. The Earth is spinning faster now. The night and the morning come earlier than everyone is used to. Earth rotation speed has increased and reduced the number of hours per day to 15. People suffer from insomnia or oversleeping. The body needs time to get used to it. Work schedules are changing all over the world. Previously, people came to the office at 9 and left at 6. Now, they arrive at 7 and leave at 2 p.m. Sleep time got shorter, and people are really sad because of this. Progress slows down because the short working time. The technologies of the future are now 20 to 30 years late. Hourly pay remains the same, so bosses now pay less for fewer working hours. The whole moon stabilized the weather and climate on the planet. Look at Mars. It has 2 small moons. They quickly spin around it and rock Mars around on its axis. As a result, strong winds, sandstorms, and thunderstorms often happen on the red planet. Now the half of the moon that approached us takes the Earth out of stable rotation. This changes the seasonal temperatures in the world. It even gets hotter in hot places. And snowstorms are raging in cold regions. There are short, massive downpours instead of sunny weather. A typical breeze can grow into a hurricane and small waves into a tsunami. The seasons are changing faster now. Winters are colder and summers are hotter. Changing the rotation of the planet affects the Earth's magnetic field. Since the compass and navigation systems are unstable now, we need to recalculate where the north and south are. Birds can't fly south to wait out the winter since they don't know what direction to fly. Their inner compass is broken. Several hundred years have passed. People are entirely accustomed to the new conditions on Earth. New species of animals and fish have appeared. Birds can navigate the sky by the moon again. The planet's economy has been restored. Hourly wages have become higher. People now get enough sleep from 5 to 6 hours a day and work for 4 to 5 hours. The reduction of day and night has also affected the entertainment industry. Movies now last 1 hour. One episode of some TV series lasts 30 minutes. Life goes faster. An average person now lives to be 96 years old. In fact, the passage of time hasn't changed at all. Its calculus did. Several thousand years have passed. People look different now. Now they have big eyes that absorb more light. Half of the moon doesn't shine as bright as the whole thing, so the nights have become darker. It took the human eye a couple of thousand years to develop the ability to see clearly in this new dark. Animals need to navigate better in these conditions, so their eyes have become larger and more sensitive. During all this time, people have cleared the orbit of moon rocks. Several space stations fly around our planet. And again, people hear this strange voice that once told them that they were all characters in one hypothetical YouTube video. This time, the voice says, "Your story ends because the video ends. I'm sorry. Good night."